this does not mean the NULL data. Actually, there is no data, not existing, nothing. Okay? Nothing there. Why? We actually the grouping the information to define customer. Sometimes customer does not have a home phone number. Do I need to eliminate this customer because of the home phone number? Then we will lose some information. Right? What about the office phone number? Benjamin Mayer does not have any office number. He is a house husband. Right? At that time, do I need to take out the Benjamin? No, we lose one information, important. He spent a lot of money. Okay? To address that problem, even though there is no data, to make the common attribute, we will consider there is no data. To represent there is no data, we use NULL. NULL does not mean this. NULL means either this one or this one. It's empty. Okay, nothing there. That's the difference from other data structure. How to compare this one and this one? Doesn't make sense. Null cannot be compared. Even null cannot be counted. Null cannot be operated. Null cannot, because it's nothing. How can you count? Nothing. Okay? So that we will address such a problem later by defining new operation. For example, we have 5 tuples. Value not this one, 1, 2, null, 3, 4. I try to average of this. What it will be the average. And let me change. 1, 1, 1, 1. Is it 1, 1 up? Or 0.8? 1 or 0.8? 0.8? 0.8. It's a 1. We cannot count not existing things. Is it 0? No, it's not 0. It's not existing. Okay? 0 means 0. But null does not mean 0. It can be anything, no. It's nothing. So don't be confused. The meaning of null, it's not easy actually. That's caused sometimes a serious problem or in the real system. Okay? Like the balance of the all customer, average of all customer. Then, as we are learning what? Concept of relational model. So model means it's group of bunch of constraints or characteristics or conditions. So we will see such a characteristic of the relation. First is the ordering set. However, that order is not very important. You don't have to pay attention. Okay? Values in the tuple, like this one, this one, this one, this one, should be atomic. Atomic means individual. You cannot segment, you cannot divide into 2 or 3. It's atomic. Okay? For example, here, this data is as it is. Okay? This is one value. This is also one value. This is one value, not 749 and 1253. It's just one value. Okay? That's a very important characteristic in relational model. That is the one reason why we identify multi-value. We identify this, but I set aside at the time why we need to define multi-value. Because there's no way to represent multi-value in terms of the definition of relation. Values should be alternate. That's very important. That is a huge limitation of using relational model. So we already go through this one. So we can represent the student with the attribute, something like that, and set. Also, R, sometimes to represent the attribute, we can use the name of relation as the R dot A. For example, customer may have the name. Student may have the name, but their names are different. So, to differentiate their name, so we can use the name of relation, then followed by dot attribute. Okay, I dot A, customer dot name, student dot name, so on. There are three very important constraints. Okay? First one is the key constraint. Next one is the entity integrity constraint. The third one is the referential integrity constraint. That is different from other DBMS database model. Okay? What time is it? 2:30. 15 more minutes. Okay. Where's my phone? So key constraint. First, we need to define what is a key of relation. We learned about briefly key, same thing in the relation ER model. Key attribute, what is a key attribute? As long as you can identify the entity, okay, entity, that will be key attribute. How many key attributes? One or more, sometimes nothing. That is the ER model. In relational model, that set of attributes. For example, in customer, we have name, social security number, and address. Do you have any attribute that can identify specific customer data? Yes. That is SSN. What else? In common sense, no. However, what about social security number plus name?
No.
Yes. Right? SSN. SSN plus address. SSN plus name plus address. The time is called super key. Super key is any combination of attributes that can identify the data. How many super key can you find from each? Sometimes nothing, sometimes one, sometimes two, sometimes many. Okay, or any combination of such a thing is considered as super key. In your case, because you are genius, you already know social security number is unique attributes. So you complain why we need to add. Think about vice versa. You do not have any idea. You need to investigate all the data, okay, by attribute. But you realize sometimes the social security number plus name can identify. And social security number can identify. Social security number plus address can identify this, also identify attributes. So we define this set of attributes are super key. There are many super key. Among them, minimal super key. I know they are useless. Without helping of this social security number itself can identify the data, right? So at that time, this SSN is called key. So finally, we define what is a key. It's a minimal super key. Okay? How many key in R? How many? One. In this case, one.
One more. Already.
Sometimes you can have multiple super key. For example, this is not customer, this is employee. Employee. So you have employee ID. So employee ID can be key, social security number can be also key. So there are two keys. So in relation, what about relation without the key? We will see later. So far, we don't know whether relation allow no key or not. But it is true one or more key, like this one. ID and social security number can be key of R. However, we need to pick up one of them for primary to represent this. So we can select one of these as the primary key. Somebody already mentioned about the primary key when we identify the key of entity, right? That is primary key. So primary key, how many primary keys for each relation? Only one. How many keys for each? Multiple. Okay? So don't be confused. So you need to select one of the keys as the primary key. The question is, how can we identify? How can we decide? Which one is better? Both of them are unique. It depends on the situation. What kind of situation? Application analysis. Okay, data analysis. You need to decide. For example, in this case, employee relation, when you investigate the whole application requirement, 90% of the application access employee by using ID. At that time, ID is better than social security number. However, for example, you are developing payroll office system. Payroll office like social security number. Okay? So it depends on who needs to decide. You, as a developer and designer, you need to decide. I can guide, but I cannot let you know which one is better. This is your responsibility. Okay? So primary key can be underlined. The other, for example, I select the social security number as the the ID as the primary key. What about the social security number? Social security number still can be used for unique key. Still a nice tool to identify the employee, so it will be used for unique key or secondary key. That is called the secondary key. Okay. Not here, it's called the secondary key. Okay. So in this case, what is the super key? There are many. License number plus engineer social serial number, license number means or combination. Okay? What is the minimum super key? What is a key? License underbar number 1, engine underbar serial underbar number. We have 2 keys. We select the license underbar number as a what? Primary key. This one is the secondary key. Okay? The next one is, this is the key constraint. So key constraint is, we can find the super key, and the minimal super key is the primary key, it's just one, and the other will be the secondary key. The next constraint is the entity integrity, that is, the primary key should be not null. Why? So far we do not discuss about whether primary key is null or not. Key is null or not. Okay? However, if primary key is null, can you identify specific person or the customer? No, that doesn't make sense. So primary key should be first unique because of the key constraint. Plus primary key should be not null. That is the reason. If you read the textbook or if you are doing the Googling, sometimes definition of primary key is non-null plus unique. You can find such a definition. Yes, that's true because of this one. So entity integrity means the primary key should be not null. Okay? Then the last one is the referential integrity. Referential integrity is the most important. The integrity in relational model comparing to others. For example, so we have employees who works for the department ID and also department. Department name, supervisor. So we identify the two relation, sources, and primary key is underlined. So we are going to add the new data to employees. No problem, we follow the reference at the key constraint, unique and non-null constraint of a primary key, then so on. Also, in case of null data, we can put the null. What about this one? Department ID 1. Does it make sense? That number 1 should exist in the department. How can you hire the person who works for ghost department, which does not exist in your company? That doesn't make sense. So this department ID should exist in this department table. We need to represent such a constraint condition. How? Using arrow. This data should exist here. Name HR supervisor lead. Like that. So this is called referential integrity. This is a referencing table. This is called reference to table. Starting arrow, ending arrow. Referencing, reference. DNO should exist, DNO in employee. This is very important, the integrity comparing to other DBMS model, the database model. Hierarchical database does not have this. Object-oriented does not have such a thing. Okay? This is only, but very, very important. The integrity in relational model. Why do we need such a thing? Because we model entity, table, relation, that has the same meaning, to reduce redundant information. However, what if we need to connect two relations? At that time, we need referential integrity. That's the only way to connect, to combine these. Okay? In other words, this is called what? Foreign key constraint. Foreign key. Have you ever heard about the foreign key? That is a foreign key, concept of foreign key. Okay? So you need to create such a foreign key constraint when you design your database, but many of the real systems do not create the foreign key constraint. What about your programming project? Did you create the foreign key constraint? You create the 4 or 5 tables, then insert the data, then access the data, and return shows a nice graphical user interface, then you got the A, right? I'm not sure whether you got the A or not. You do not create the foreign key, but you got the A. Foreign key, sometimes you can ignore. But if you do not create the foreign key, you cannot guarantee the data. Okay? How can you overcome such a problem without foreign key? In your programming language, programming level, you can check whether DNO1 is real or not. It's a programming level. That's true in real project. Even from time to time when I worked for the database administrator, I consult the database in other companies. At the time, I realized sometimes there's no foreign key. Why? It's a too strong constraint and very hard to manage. For example, I have a new student who does not register yet. Okay? Because of that, it violates such a foreign key constraint. So, no, you cannot come into my class until you register. That's not polite. So I can allow the exception, but this one does not allow any exception. It's too strong. I have new employees, but we need to wait for a while to assign the new employee to the department. If we have such a foreign key, you cannot hire the person. You cannot give the salary. So that is a reason. However, I strongly suggest to create and manage the foreign key to keep the validate of the database. That is the referential integrity. Okay. There are other types of the constraint. So far we have learned 3 constraints. Key constraint is unique, and the entity constraint is a primary key, not null, and referential integrity. 2 table, 2 relation, and referencing and reference. The next one is the assertion constraint in the specification. In other words, it's a trigger or the assertion. For example, I allow the student whose age is between 20 to 25 in my student table, in my student relation. That's a very specific constraint. How can you specify such a constraint? You can check the constraint in your programming language. Many of you are doing such a way. But using the trigger or assertion, you can check such a constraint, whether it's okay or not. Eventually, we try to build such a relational schema. It's our goal. Our goal of relational model. So with foreign key. So this is our goal. It's called the relational schema diagram. It's a relational model. How long it takes to learn the relational model? Just 1 hour. That's the benefit of using relational model. Even company, they don't have to spend a lot of time to train the employee. Even they never teach what is the relational model. Eventually you can learn. Okay? So that is a benefit of using the relational model. This is our goal. This is your goal also in your project. Based on your requirement for online banking system that you submitted the last week. So you are going to do this one in step 2 and then followed by the relational schema diagram in step 3, step 2 initially. So step 2 or 3. Okay. In addition to such a constraint, database model, data model requires some operation. Operation is kind of method in object-oriented concept. How to access, how to manipulate the data. So for that operation, we have insert, delete, and modify. Update. Okay. Update operation. We will learn such a thing in SQL language. Okay. Okay, so pretty much that's it. Why don't you, when you have a time, it's not homework, because it has the answer. Next slide. Take a look at the exercise. Any question? That's a good question. We will see later. Okay? Before you leave,